All right, so for our last part, perpendicular and parallel slopes and equations, we have to just remember if it's parallel, it has the same slope, same number. Okay. If it's perpendicular, it will have a opposite or negative reciprocal slope. Sorry, I meant to fix that. Opposite reciprocal slope. That's when we flip the number and change the sign. Okay. Change sign. Now, if it's neither, it means it's not the same or it's not a flip and change. So on here, all we're going to do to determine the slope, if I've given you 2 points, is use the slope formula, which is y2 minus y1 over x2 minus x1. So you need to do each set of points. Like if I do AB, that slope, I'm doing -1 minus 5 over 3 minus 6, sorry. Then simplifying that. This comes out to a positive 2. Then we're going to do the slope of CD. That's -4 minus 2 over 7 minus -5. I believe this comes out to be -1/2. If I compare these two numbers, 2 and a -1/2 is a flip change. So this is perpendicular. So this is what you're doing on these set of problems, okay? Please use your formula, use your calculator. Remember, you can put this in the calculator. Like if I'm doing the AB on 63, I could just go straight to the fraction box. It's coming on. Just give me a second. Let me get there. There we go. You can go to the fraction box by doing alpha y equals, hit enter, and just type in the setup. So AB is 2 minus a -2. Oops, I didn't put my negative, sorry. 2 minus a -2, -1, okay? And then our x2's minus x1, so I just need an arrow down. That would be our -4 minus -8. All right, and then if you just hit enter, it would go ahead and simplify that for you. So AB is 3/4 here, okay? You need to finish this. I'm not really gonna do this. This should be, oops, sorry. This should be double review because we did this in Algebra 1 as well. So just determine if the numbers are the same, if they're a flip change, or neither of that, okay? All right, now I am going to show you some shortcuts for this last section because now we're writing equations or determining if they're parallel by looking at the equations. So the only way to see, just looking at the equation to see if it's parallel, see the slope, is in slope-intercept form. Let me do this way, sorry. Which is mx plus b. Because the m, anything in front of the x, if it's in this form, that represents the slope. So if the equation, like if I look, I have two equations here. I have the 4x minus 2y equals 6, and I have the y equals 2x plus 7. This first one is already in slope-intercept form, so I know the m is 2 here. The second one, sorry, this one right here. The 4x minus 2y is not. So what I would need to do is put it in slope-intercept form by minus the 4x to isolate the y term. This will give me -2y equals a -4x plus 6. Just rewrite it. Then you're going to divide everything by -2. So y, because that would cancel here, y equals positive 2x minus 3. And I can see here, this is the slope. These are the same. So the answer is parallel. Okay. Now there is a shortcut you can use if it's in standard form. So like this first equation here is in standard form because you have ax plus by, the x and the y terms on the left side of the equal sign equal to c. Now if this is, if the equation is in standard form, the shortcut to get to the slope is using this formula, m, which is a symbol for slope, equals -a over b. You take whatever the a value is, like on this one, the a is the 2. I'm going to write -2 over b. And here b is like this invisible 1. And it's going to be a -1 because it's a minus sign here. This actually comes out to be a +2. Then I look at the next equation. Y equals -1/2 x plus 1. The -1/2 is the slope, so -1/2. I compare these two numbers, a 2 and a -1/2. These two numbers have been flipped, and we have a sign change. So anytime we have a flip and a sign change, they're perpendicular. So I don't care which method you use, okay? If you're good about seeing your A and your B, and making sure you're only changing the sign of the A, whatever sign is in front of the B, you keep. Like on example here, the A is the 8, the B is this -4, so this would be -8 over -4, which reduces to +2. And then this one is a -2. These are just a sign change, so this would be neither. Okay, so if you want to solve for y, like 68, there's my slope. This one would be easier to just solve for y by divide everything by 2. And then if you like just solving for y, just do that method. If you understand how to do the standard form and seeing the -a and the b, then you can use that. I'm not going to specify which method you have to use. So you're going to finish this. On 69, you have to remember our special types of lines. For example, if I have HOY, anything y equals a number, which means you would have a horizontal line. So this first equation is going like this. Okay, first equation, horizontal line. And then if you remember the other acronym, which is VUX, if I have x equals a number, that's going to be a vertical line. All horizontal lines and vertical lines are perpendicular. They intersect, making a right angle. Okay, so they're perpendicular. The other parts of OIVUX, this is meaning zero slope. Zero slope. And this would be undefined slope. Okay, but you don't need the slope. You just need to know what type of line it is. Okay. Then from this point on, we're going to be using point slope form, which is y minus y1 equals m parentheses x minus x1. You have to remember our m is our slope. So here our m equals -6. Our point is our x1 and our y1. So we're just plugging the parts in. This would end up being y actually plus 2 equals the -6 for the slope. And then we would have x minus 3 inside the parentheses. Okay. So there is our point slope form. Now to put this into slope intercept form, which is what this problem says, you have to do your point slope first. And then the second thing you're going to have to do is then distribute and solve for y. And solve for y. Okay, so I'm going to do it on this, since it's already in point slope on this one, except distribute here. When I distribute, I'm just going to write it over here to the side. You would have y plus 2 equals -6x plus 18. And solving for y means you subtract 2. And so y equals -6x plus 16. Okay. So if I'm doing a slope of 2/3, meaning m equals 2/3, and I probably should have did that in blue. Keep it the same. And then I'm doing a point of -6 and 4. So that's my x1 and y1. You're going to start off with y plus 4 equals 2/3 parentheses x plus 6. Then you're going to need to distribute, solve for y. Okay. Now, on the last part, we just got to remember our slope relationships. For example, on 73, the keyword is we want the perpendicular. So it has to be perpendicular to this slope, which is just this number. And the perpendicular would be a positive 3. And now we're using this point. So we're starting off with y minus 2 equals 3, parentheses x minus 3. Then we're going to distribute. So everything stays y minus 2 the same, but then we now have equals 3x minus 9. And then we're solving for y. So we have to add that 2 to cancel. And we get y equals 3x minus 7. Okay, so that's what we're doing here for the remainder. Perpendicular, make sure you find the slope first. So you need to use these equations to find the slope. Either put into y equals mx plus b, or use your negative a over b. And then do the perpendicular of that. So you need the perpendicular, okay? And then you have a multiple choice down here. Remember, I think the shortcut is easier here, but whatever method you like. All right, finish this up, and that takes care of everything. All right.